everybody, and good afternoon to this Epic Members new product release. It's our first meeting after summer holidays, so I hope everybody enjoy your holidays and have a pleasant and relaxing time. As probably most of you know, the goal of this meeting is to know more and understand the new releases and new developments of the Epic members. So the 5 companies you see in this page will present their new solutions, and we will know more about the specifications, the characteristics, applications they have in mind, and we will also understand more details about their developments. We will have presentations from the companies Hamamatsu, TOPPAN, Optofidelity, Excelitas, and Arden Photonics today. So I'm very excited because there are several topics very interesting for me, and I'm really interested in knowing more about their solutions. And just a few words about Epic for starting. You know that we are the European Photonics Industry Consortium, an association of more than 800 companies with the goal of ensure the sustainability of the photonics business. Our goal is to connect people to help you to find new partners for developments and collaborations, to find potential new customers, to find also answers to your technological requests, and to help you in any field that you consider we can help with all this network of companies, and also the companies we contact outside the consortium. I already made a summary, but these are the benefits that we offer to our members to help them with the technology requests in case you have something that you want to explore different alternatives in terms of a product, or you are exploring different solutions and you want to be connected with any company that can provide it. Also to give you more information about market and technology reports. As I mentioned, also networking, help you to connect with different companies that can be future partners or collaborators. Help with access to markets and mentorship, and we also help with human resources support with the website Jobs in Photonics, in case you have any open position that you want to promote, and in case you are a company interested in being contacted by investors or interested in investing in startups, small companies, spin-offs, and so on. We can also do this work for you, and we organize different activities to put people in contact that could be interested. Regarding the networking and technology offer, just a short summary about the future Epic events, because after summer holidays, we are back in our physical meetings. We were already chatting a little bit about the previous one we have in spring this year. So we have here a summary of the events we will have in the next weeks. In September, 2 in-person meetings in France and in Switzerland, one about photonics for space, and the other is photonics for bio and life science applications. Then in October, we will go with Epic meetings in quantum photonics at Optica in Munich, and also laser applications related with the battery manufacturing process in Stuttgart in Germany. So the registration for these events is still open, so feel free to go to our website and check the agenda, all the topics we will cover there. I think in some cases could be interesting for some of you, because they can cover topics that are under your umbrella, or they are your goal in the future. We will be also present at ECOC in Glasgow, so we will organize different activities, including an Epic and Ethernet Alliance meeting, and also an Epic Tech Walk during this conference. And then about the online meetings, also some information below, because we will start again with online technology meetings. You will see one in hybrid photonics integration in September, another one in optical metrology solutions for the industry in October, and another one in LiDAR on chips in October. And we will continue with other online meetings to cover the different topics that are interesting for you. For example, the work group on sustainable photonics that we start before summer, also with a meeting in laser world photonics. And we find that people is really interested in the discuss about the sustainability in the production of photonics and photonic components. Also, we will continue with our marketing meetings. So feel free to tell to your marketing departments that we will talk about Google Analytics in October. And then we will continue with the technology reports. In this case, we will have Oliver Fanley to talk about, make a report about freeform optical systems. So I guess it's going to be also interesting for some of you. And as I mentioned, a very interesting set of companies for today. We will cover different topics from fibers to lasers, also analysis testers, and lamps. And this is the agenda for today. And as you see here, we will start with Naveen Balla. He's a technical marketing engineer at Hamamatsu Photonics, and he's going to present the world's smaller UV excimer lamp. So Naveen, I will stop sharing my screen, so feel free to share your presentation and start wherever you are ready.
Thank you, Antonio. I guess you can see my screen, right?
Yes, we can. Thank you, Naveen.
Okay. Okay. So hello, everyone. My name is Naveen. I am a technical marketing engineer at Hamamatsu Photonics. I would like to thank Epic for giving us this opportunity to present Excimer pen, which is arguably the world's smallest excimer lamp in a particular form factor. I mean the pen type lamp, and I'll explain why we call it so. First, I will start with a brief introduction to Hamamatsu and then move on to the actual product, explain its specifications and its target applications. Most of you are probably familiar with Hamamatsu Photonics. We have been around for about 70 years, producing a wide array of products, photonic-based products. So there are about 15,000 active products currently available. We are about 5,500 worldwide, with most of our R&D and production based in Japan, and sales and marketing spread all over the world. Vacuum tube technology and its combination with optoelectronics has been one of our core strengths, and it is best exemplified by our products, the PMTs, as you see on the left, and our lamps on the right side. These have been serving the optics and photonics community for a long time. And the Excimer pen is coming from this particular heritage of technology. It is a small cylindrically shaped lamp, which is about 6.5 millimeters in diameter and 80 millimeters in length. So quite small, but it packs a lot of power in it. Its emission is in vacuum UV, so less than 200 nanometers, specifically 172 nanometers, and it uses a xenon-based excimer for its emission. So when I say excimer, it is usually an excited dimer, and here that excited dimer is a xenon molecule. The emission is quasi-monochromatic. It's centered around 172 nanometers. And this lamp, with this vacuum UV lamp, is free of any hazardous materials like mercury. It also is, the excimer technology is also different from the metal arc lamps. So it usually operates at a lower temperature, and hence it's easier to integrate into systems. The UV irradiance is quite strong. It's about 7 millimeters per centimeter square and has a reasonably long lifetime of about 2,000 hours. Yeah. The applications of this excimer lamp are all based on the power of these vacuum UV photons. So 172 nanometers is about 7.2 electron volt. It means that when these photons interact with any chemical whose bond strength is less than this energy level, then it's highly likely that those bonds can be cleaved. And here are a list of few mostly organic chemical bonds which can be easily cleaved by this excimer radiation. Now, the applications, as I said, are all based on this principle. The first one would be the measurement of total organic content as in water. So it usually refers to the amount of unwanted organic content in water. And one standard way of measuring it is by oxidizing the organic content, either by chemical means like catalytic oxidation or by exposing it to high energy photons like excimer lamp and oxidizing them into carbon dioxide and water vapor. And you can measure the carbon dioxide by spectroscopic means and back calculate the TOC. And there are well-defined regulations on the level of TOC in water for different purposes, drinking, used in pharma industry. So this is an important application for excimer lab. The same principle of breaking down or oxidizing organic materials into can be used for eliminating VOCs or volatile organic compounds which result from certain industrial processes. For example, in when resins or certain types of resins or inks are made, they are usually in a suspension of an organic solvent, which when it dries out, which when dries out leaves these emits these organic uh, compounds, which can be very harmful. So they can be oxidized into less harmful carbon dioxide or water vapor. So that's another use of this X-pen or XML lamp. Then along the same lines, we have another application in small water purification systems. I'm talking about benchtop systems, portable systems, where instead of just like measuring TOC, you can use it for a prolonged period to get rid of the organic content in the water. That's yeah, but given the size, it is really meant for the small systems, not the large systems. Then we have another application, which is surface modification. Here, the principle is the same. You use the excimer radiation to remove organic materials on a surface before you apply a coating on it. But given the shape of this lamp, it is more easy to. You can access surfaces which are not otherwise easily accessible by a flat or lamp or a large lamp. So inside, I'm talking about specifically inside of a bottle. Okay, my pointer is not working. Okay, never mind. Yeah, okay. Insides of a glass bottle, so it is not easy to go through outside of the bottle because the UV radiation would easily decay if you go through the glass. So it is best to go from inside, and hence the form factor of X-pen would be very useful. The same, again, the same principle can be used to uh, um, treat the surface of resins, making it more mechanically and chemically resistant. So that's the last application I would like to discuss here. In terms of competition for this lamp, I think low pressure mercury arc lamps are the closest. Uh, these are based on mercury metal vapor, but they are not monochromatic. So you get multiple spectral lines from it. So if you are using any kind of a measurement system where you don't want unwanted spectral lines, then it's probably not the best choice. Also, a big advantage of X-pen is that it doesn't use any hazardous materials like mercury itself. Though the lamp being based on the excimer technology is more an instant on and off technology, so you can switch it on and off. But mercury arc lamps usually require a warm-up time where the metal gets converted into vapor and then it's ready to emit. A form factor again is one of its key strengths. It's really small, so in UK it's easier to integrate, and also the temperature, low temperature operation makes it more easy. to integrate without worrying about high temperatures, which are usually encountered in metal arc lamps. The last point is its high irradiation. It sounds low, 7 milliwatts per centimeter square, but vacuum UV irradiation light sources are not that powerful usually. Even the mercury arc lamps, uh, their energy is spread out over multiple spectral lines. So when we are talking about pure vacuum UV emission, the net emission may not be so high. So that's these all advantages definitely put XPEN as a worthy challenger for these low pressure mercury arc lamps. And that's what I would like to present to you, a very environmentally friendly vacuum UV lamp, which is fast to operate, gives out a strong irradiance, and its form factor is very easy to handle and to integrate into systems. Guess that's all about XPEN. If you have further queries, I can take some questions, or you can write to us, myself, or the general email ID at hamamatsu.eu.
Thank you very much, Naveen. And as he mentioned, it's time for questions. So in the menu at the bottom, you will see raise hand. So feel free to push this button if you want to make any question to Naveen or any of the other speakers. I can start because I have a couple of questions. And the first one is about the product itself, just showing a picture here that is very nice. Is this the solution you provide, or are there different kind of electronics? I'm thinking in a rack solution, for example, or other kind of enclosure for the electronics, or is this the solution that you provide?
Oh, I think let's say, okay. So we sell the lamp and the electronics like separately. So it's up to you. We can buy the lamp. I guess is a standard format. And the electronics. So this is, I think, a driver board which we provide. But if you have a specific requirement, or if you want to connect multiple to a single driver board, that's something which can be discussed with our engineers.
Mm-hmm. And my second question is related with the application in the coatings you mentioned. If I understand well, the idea is that the coating company should apply the light before applying the coatings to the surface. I don't know how long. Is there any limitation in terms of time where they do this application of the light before they proceed with the coating? It's something that they can do in the liquid. They can store it for a while and then proceed with the coating. I don't know whether this effect that you mentioned is permanent. Is there some lifetime in the effect? I don't know if you can explain more a little bit of this application.
Yes, I think so. Before applying a coating, if you want to clean the surface, then you have, I think, I can't specify a particular time limit, but what the lamp or the UV irradiation does is basically oxidizes everything on the surface it is exposed to. So it gets vaporized, and now the surface is all charged and ready to stick to something else. Now, we always have dust and other things in the surroundings. If your environment is clean in which you are doing this, it can, I think, the surface it remains clean for a longer time. But if it is not so clean, the dust particles can easily stick to it. Water vapor can stick, basically settle down on the surface because it is highly charged. So it is best to not wait too long and apply your coating as soon as you do the treatment.
Good. Thank you, Naveen.
Mm-hmm.
I don't know if there is any other question in the audience. If not, you saw the email from Naveen, so feel free to contact him afterwards to discuss about any curiosity or any question about this product in particular. And thank you very much for your nice presentation and your explanation to my questions as well. And we can go, thank you. And we can go now to the next speaker. We have Andreas Frangen, Senior Account Manager at TOPPAN Photomask, and he's going to present the NIL Masters for an application that is quite hot now in Epic, like AR, VR, and also MetaLens. So Thomas, you can, or Andreas, sorry, you can share the screen wherever you are ready.
Yes, I will. Yeah, thank you. Thank you, Epic, for giving us the opportunity to provide or to offer our product here today. My name is Andreas Frangen. I'm a member of the new business. Can you see my screen? No?
We don't see the presentation. You need to share it again, probably.
Oh, I shared. Okay. No.
Good.
Okay.
Now it's full screen. Good. Thank you, Andreas.
Yeah, I'm a member of the new business development team in TOPPAN, and I would like to give you a short introduction to TOPPAN Photomask. And the product we want to launch today is nano imprint masters for the AR, VR business, and also for MetaLens applications. Yeah, TOPPAN Photomask is the world's premier provider of photomasks for the semiconductor industry. And we have the technology also to provide industrialized nil masters for AR, VR, but also for meta lenses and also other applications, of course. And our masters benefit from the semiconductor industry standard quality. And our offer is nil masters on 6-inch square form factor, but also on 8-inch round silicon form factor. I want to focus a bit on 6-inch square today because it has some advantages, we think. Who are we? TOPPAN Photomask is we belonging to TOPPAN Printing, Japanese company as well, same as Hamamatsu. The Photomask business unit is independent since last year. We are present worldwide. We are basically everywhere where our customers are. And among these, pointer, among these sites, there are 2 R&D sites that are at the same time our nil manufacturing sites. One is Dresden in Germany and one is Osaka in Japan. And what do we offer to the industry? Of course, as our name says, making photomasks primarily for optical or deep UV exposure, but also EUV mask for the latest technology nodes. And what I want to promote today is nil masters on the same form factor as we are making photomasks, which provides some advantages I would like to explain in the following slides. You may know there are a couple of different mask technologies available, simple binary masks, there are embedded phase shift masks existing, but there are also quartz-etched photomasks existing since 20 years already. They're called alternating phase shift mask or chromeless phase shift masks. So this is already an established process with the quartz edge. And one can consider a nil master as an evolution of a quartz edge photomask because they can be, or they are manufactured at the same tools, same process line, applying the same quality standards as photomasks. And what we did, we added a few new capabilities to that process, to that edge quartz etching process, to allow us to achieve new properties like very deep gratings on top of here, or for meta lenses, you want to achieve very small feature sizes of the meta atoms, and even non-binary, also staircase pattern, for example. We are targeting 2 major market segments, as already mentioned, the AR, VR, waveguide applications on the one hand side, but also meta lens-based optics both of them have their own requirements, specifics. Like for meta lenses, you need very high resolution. You may want to have meta atoms of not only round shape but also arbitrary shapes, triangles, and so on. And the AR, VR waveguide applications, they primarily consist of gratings, but many of them, some of them, not only need binary gratings, but you also want to have non-binary or non-vertical grading profiles, for example, or even various edge depths. And how we can support that, I will show on the next slides. What we can manufacture is, or one is staircase patterns, for example, or so-called multi-step patterns. With that, you can realize several optical functionalities. On the right-hand side, a real multi-step pattern where you could realize diffusers, for example, or other functionalities. On the left-hand side, you see a generic staircase pattern that can be used in optical waveguides to achieve certain optical properties. For example, if you have an in or out coupled grading at a waveguide, you may want to have a better diffraction efficiency in the preferred direction. Another option that we can realize with our processes is slanted gratings. So you would achieve an even better diffraction efficiency if the gratings have a certain slant angle. This can be manufactured as well. We do have an edge tool that can tilt a mask and can realize such kind of tilted profiles. Here you can see a few examples of several slant angles and depths. So that process is available as well to the industry for product demos and prototypes, and will be available for high volume production soon. The same tool can be used to realize different edge depths on one master, or we can realize a certain depth slope across a grating, for example. It can be straight or slanted. So one application is, for example, if I have an out-coupled grading at the waveguide, it may require some compensation of the light intensity along the grading. So this process is also available for product demos and prototypes right now. Finally, meta lenses. We are well able to provide masters for meta lens applications, meta optics, and are able to realize not only round-shaped meta atoms, but also meta atoms of arbitrary shape. This is a generic pattern. It's a non-functional meta lens, but it's intended to show that we are able to pattern these. On the top row, you see the design data. The center row shows how it looks like on the master, on the quartz-edged master, and the bottom shows the imprint. And what we want to disclose is that we are well able to manufacture those kinds of masters, and the nano imprint technology is well able to replicate these patterns at very high pattern fidelity. So thanks to EVG, we have run these experiments and offered this technology to the industry. To summarize, our Photomask technology is well suited to manufacture mill masters as well for advanced optical devices by adding additional functionalities like slanted edge. So we offer we call it industrialized setup for prototypes, but also high volume manufacturing of masters. We have an excellent understanding and implementation of special requirements of mill masters due to the fact that those products run at the same production lines as Photomask. You have access to high production capacity or high e-beam capacity. I think this is an advantage over the round silicon wafer-based masters to have more capacity available. And another advantage is that those processes are run under well-controlled conditions, so defect-free environments, so tightly controlled processes. I focus a bit on 6-inch square form factor in my presentation, but of course I should also mention that we are also able to provide 8-inch round silicon form factor. This is available with similar capabilities. Thank you very much for your attention. And if you have any questions.
Thank you very much, Andreas. Really impressive, the pictures. I have a question regarding the angles, because I think you show up to 45 degrees. Is this the limit to make the structure, or can you go to also, well, it's no longer, but the higher angles depending on the requirements?
Well, if the requirements you have been receiving so far were up to 45 degrees, might not be the limit, but it's well manufacturable.
Good. Any question for Andreas? I would also like to make another question, and it's related with the main challenge when addressing AR/VR applications. Is the structure they require that is a challenge for you, or is more to keep this precision that you mentioned, or limitation of the errors and the accuracy in the process?
Well, compared to standard Photomask, I think this structuring is less of a headache. So the stability requirements are more. I mean, it's different. I mean, creating waveguide people are more focused on pitch stability, for example. Whereas on Photomask, it's more important to achieve a certain CD stability or placement stability. So it's a bit different, but the established Photomask processes are well able to meet the requirements of the AR/VR waveguide customers.
Yep. Good. So if there is no more questions for Andreas, I thank again for your nice presentation and these impressive pictures of your capabilities. So thank you, Andreas. And we can go now with the next speaker. We have two persons to introduce: Arden Photonics, Thomas Leo, marketing manager, and Kit Buchanan, a product designer. And they are going to present, apart from Arden Photonics, also the new optical fiber measurement solutions for specialty fibers. So Thomas, I think you will start. You can share your screen. You are muted right now. You have to unmute on the bottom on the left.
Okay. Can you all see our screen?
Yeah, we see you with the presentation and we hear you.
Okay. And so good afternoon, everybody. My name is Thomas, marketing manager, and this is Kit, our product designer. And it's a pleasure for us to introduce our new product to you in this webinar for the fellow EPIC members. And about Arden Photonics, basically, we are an optical fiber testing instrument manufacturer. We produce testing instrument to help optical fiber manufacturers to make better optical fibers for a better tomorrow. And our headquarters is based in Solihull, which is the center of England, and actually it's very close to the birthplace of William Shakespeare, one of the best playwrights in the world. And we have our company was founded 22 years ago with our years of experience and also expertise in the optical fiber measurement. We have various skills and also expertise to measure a variety of optical fiber properties For example, we can measure the end phase inspection of the fibers. It will be very useful for the splicing of the optical fibers, fiber geometry, and also multimode launch condition, and also measurement as well. And for this time, we are going to present 2 new products which we launched in early this year. One, our modal content analyzer 1550 was launched in June, and also our refractive index profiler was launched in April this year. And our product designer Kip will help us to present the product in a technical prospect.
Hi everyone, my name is Kip Buchanan and I'm a product design engineer here at Arden Photonics. So today I'm going to talk to you about 2 of our latest product developments. So firstly, today we have the MPA 600 refractive index profiler and accompanying version 2 software update. So the MPA 600 adds additional capability to our existing NPA platform and allows the quickest and easiest refractive index measurements of fibers now up to 600 microns in diameter. So the MPA 600 retains the ability to measure complex geometry, including octagonal, multi-core, and other non-symmetrical fibers. So it makes it an even more valuable tool for measuring specialty, active, and laser fibers. The new version 2 software update allows users to dive deeper into the refractive index measurements and more easily extract the information that they need. So new templates, output tools, and APIs allow the MPA 600 to be rolled out into the production environment. In addition, we've got new calibration tools which help ensure consistent, highly accurate results. So just as an example of the MPA 600's capabilities, Arden was able to work with the University of Hanover to measure some of their multi-core fibers. These are fibers that have been developed by them for use in researching small diameter endoscopes. So as you can see in these images, the MPA was able to measure the refractive index for each of the 1200 cores in this fiber, each core individually only measuring about 1.3 microns in diameter. So moving on to our next product, this is a brand new CMC 1550 from Arden Photonics, and the only commercial system in the world that allows users to measure the modal content of fibers using the S-squared method. So as a bit of background for why we developed this instrument, the boundaries of fiber transmission are being constantly pushed in attempts to increase throughput and communication speeds. Hollow core and few mode fibers are some of the ways to achieve these breakthroughs. But as these fiber designs get more complex, they also become more sensitive to production issues. So a precise measurement of this modal content becomes more and more important. So CMC helps designers to unlock this valuable modal content information, giving teams a comprehensive understanding of individual propagation modes and their interactions. For each mode, the CMC provides values for the MPI, or multipath interference. This is the relative intensity of the mode relative to the fundamental. So this data can be used to ensure the right modes are being excited, whether that's several modes equally excited in a few mode fiber, or as another example, verifying minimal modal content outside the fundamental in, for example, hollow core single mode fibers. So the S-squared technique also provides the DGD, or differential group delay. So this is a measurement of the modal delay in picoseconds per meter. So the measurement also provides mode intensity and phase plots. And as with the MPA 600, simple tools allow for the exploration and export of this data. In addition, spectrogram mode quickly highlights how the modal content changes with the frequency, and loop mode provides a near real-time exploration of this modal content, basically allowing adjustments and modifications to the fiber launch to be seen almost immediately. So here we have some additional examples fiber modes taken from a short length of few mode fiber. So this fiber was designed to carry information in up to 4 separate modes, and the CMC is clearly able to resolve these modal patterns and their corresponding phase plots.
Okay, so this is a very short presentation for our 2 new products, and I'm sure these 2 new products will help optical fiber manufacturers, especially the specialty fiber manufacturers, to make better better fibers. If any of you would be interested to know more or to see a demo of the new products, please feel free to contact us. We have office in the UK and also another office which we opened only this year, and actually it's in America. So please feel free to contact us for further details of the 2 new products. Thank you.
Thank you very much, Thomas and Kit, for presenting your new solutions. As I mentioned to Jens, we were chatting, we will have next year, we are working in a special event for specialty optical fibers. So I will contact you back to define the best way for you to participate.
Yeah, absolutely.
So we have time for questions for Arden Photonics. I can start with one question, because you mentioned your solutions are interesting for manufacturers of specialty optical fibers. But would you recommend any of them also for kind of end users, for example, providers of solutions for telecom or fiber laser manufacturers that perhaps they need to check the characteristics of the fiber they are using in the products? Do you think could be also valuable for some end users of optical fibers?
Oh, absolutely. The MPA, as well as obviously being able to measure complex fibers, is perfectly capable of measuring sort of telecom fibers, and still provides the quickest and easiest measurements for measuring refractive index compared to our competitors. And it's the same with the CMC 1550. The wavelength is perfectly suited for measurements for telecom fibers.
And is there any limitation, because nowadays we see quite crazy developments in terms of fibers, any limitation to measure, I don't know, some kind of hollow core fibers, or you didn't notice up to now that there is any kind of a structure of fibers that you cannot measure with your solutions?
So yeah, we've measured some very interesting samples with the MPA, and it's been able to measure, hollow core and photonic crystal fiber with ease, just as well as it does the standard telecom fiber. All sorts of non-symmetrical square core fiber, twisted and sort of spun fiber is also measured as well.
So you have experience also with these kind of strange structures.
The stranger the better.
Good. We have a question from Kasun, Delft University of Technology.
Hi. Yeah. My question is related to the number of modes that it can detect. Like, is there a limitation when it comes to the number of modes?
So the limitations come from the S-squared technique itself. So I think typically we're sort of looking up to maybe 10 modes.
Okay. Yep. Thanks.
So if there is no more questions for Thomas and Kit, thank you again for a nice presentation. And we will be in touch for the meeting next year about the specialty optical fibers.
Yeah. Thank you.
Thank you. Thank you. And our next speaker is Murat Deveci, Director, is business development as well.
Very good.
And Optofidelity. He's going to present the WGGAT grating analysis tester. Murat, I don't know if I should share my screen with your presentation.
Yes, please, Antonio. Thank you.
Okay. Let me look for it. I think you see now. Let me put it in full presentation mode.
Yes. Okay. So thank you for organizing this session and for the introduction. My name is Murat Deveci. Today, I will introduce one of our AR waveguide optical metrology systems. But let me first quickly introduce who we are. Next page, please. Or can I do that? No, I can't do that. So, Antonio, can you jump to the next page, please?
Yeah, and trying something is happening here. Let me try again. Sorry.
Yes.
I do not find it now. Let me check. Okay, sorry. Are you there, Murat? Okay.
Yes, I am. Okay. So, well, we began devices. We provided touch testing solutions for the smartphones when they were not even smart, but when they were transitioning from clicking to the touching. Then we jump into the VR display metrology market when they introduced the Oculus. Then with the debut of HoloLens, we also started to develop our first waveguide metrology and testing equipments. Since then, we've delivered hundreds of AR/VR metrology testers. So we work with pretty much everyone in the AR/VR small niche market still. Yeah. So although our company is based in Finland, we have a global presence. Our company has production facilities in China for high volume manufacturing, in addition to the 2 US offices and multiple locations in the APAC region. Today, our goal is delivering all needed metrology and testing tools to enable our customers to have a complete traceability of their testing and metrology throughout their entire AR/VR headset development process. Thank you, and next page, please. Yeah, so today I'm going to introduce you to VG-GAT. Here, VG refers to waveguides utilizing augmented reality applications, while GAT indicates grading analysis tool. The VG-GAT is it's a literal diffractometer for measuring grading pitch and orientation in samples with periodic structures such as diffractive waveguides for AR displays. And if you are unfamiliar with literal diffractometers, quickly, a literal diffractometer is an optical metrology tool, optical device that uses a laser beam to illuminate a sample. Then the grading reflects the diffraction order back to the laser, which is then directed towards a camera via beam splitter. With direct reflection from the grading, we can calibrate the sample rotation stage to measure diffraction angles accurately. So now we know how we analyze the gradings. Let's find out why we analyze the gradings. Next page, please. So the main challenge has been with our AR customers is quantifying a good image quality results through different metrics such as MTF, such as uniformity, brightness, and distortion and such. So on the left side, you can see what is projected into an AR waveguide and the resulting virtual image that appears to the user. And on the right side, the pixels color indicates how much the grading period differs from the nominal period. So engineers and developers, optical metrology scientists from our customer space, so they adjust parameters to improve image quality, assessing the outcome by measuring the gradings. So they try to pinpoint issues with masters, replica, materials, process, any type of chemicals, or the design itself. So it's quite challenging because the tolerances to make a precise grading is quite hard to achieve because the pitch is about 15 picometer and for the orientation is about 5 arcseconds. So this makes it quite tough to achieve. But with this tool, VG-GAT, our AR customers, some of them have already utilized this in their process. So they have managed to eliminate such non-uniformities within their gradings, and they already achieved good image quality results. So they start with this VGGAT so that they make sure that their gratings are precise, as accurate as possible. Then they also measure the image quality. We also have tools for image quality, but today I'm not talking about any of those. For example, this image on the left side has been in fact captured by one of other tools that we have it. So we have this lineup of products for the waveguide metrology and testing. But the first things first, so the structural problems, the characterizations of the gratings that we tackled with this product called VGGAT. Next page, please. Yeah, so all in all, let's quickly summarize it already. So the VGGAT measures the grading quality during the manufacturing process and answers, is your grading quality high enough to ensure a high, good this VGGAT tool. So our analyzer also. And here I also shared to Vivid that these results have been verified. I would say pretty recognized institution, especially in Europe, as so we are achieving resolutions less than 0.5 picometer and a repeatability values of less than 20 picometer. For example, in comparison with what else in the market to make this kind of measurements, there is no direct competition for this product at this stage, but you can measure the gradings, for example, with microscopes, ACMs, AFMs, and such, but they take tremendous amount of time. In the meantime, for example, ACM's resolution is almost about 500 picometers, while we are having here sub 0.5 picometers. And the time to measure an entire wafer with this tester is about, I will say, less than 1 hour. But with the ACM, imagine that you have at least a couple of waveguides in one wafer. Let us assume that it's about 300 millimeter. It will take days to measure that. Because, and also imagine that you are measuring with AFM, line by line measurements. Yeah, this will take days. And then these repeatability and accuracy values of this type of non-direct competing technologies are highly depending on the operators. But in our case, with the VGGAT, everything is fully automated. Next page, please. Next one, please. And this is pretty much all. I want to take a very quick snapshot of what we have introduced to AR optical metrology market. And we have already found customers for this product. And we have received very good feedback from the masters makers, from the waveguide developing companies, and from also the brand name companies. They are working on their next generations of VR or AR or mixed reality headsets. So thank you very much for listening to me. And you can contact me for further and more detailed information. And you can also request a demonstration. So let's be in touch. Thank you.
Thank you very much for that presentation. And we have before Andreas from TOPPAN talking about similar application. I don't know, Andreas, if you see any point for collaboration here or any interest. Well, we can discuss also later on, but what's your first impression? That it could be interesting to know your point of view.
Absolutely, very interesting. And I was about to ask whether you are able to measure our masters, for example.
We have already measured all large companies' masters. I can't name the names, but I'll be in touch with you, Andreas. Yeah.
You should do that, yeah.
So no worries with the different substrate materials also. I saw that you have quartz, for example. So we have been there, so done that. So no worries with that too.
Any other question? We also have some component manufacturers in the house. We have Hamamatsu, we have Excelitas, for example. I don't know if you can explain a little bit kind of light source you use in general, or kind of detection solution that you use in your system.
Yeah, so we've been using a narrow bandwidth laser. Some of the customers select their own lasers, so it's really depending on the grading period range. Let us assume that you have a range up to between 200 and 400 nanometer grading period. So that's the usual laser that we are using is about It's about 450 nanometers. Yeah. And of course, this system may have different laser sources, plug and play with the fiber optics ready to go. So if you have a very large range for grading periods, so it could be from 200 up to 600. So we could also already line up different lasers in the station. So when you are utilizing a grading period range between 200 to 300, you can use one laser, which is more relevant for that period in order to capture the litho angle perfectly fine. Then you can utilize another laser, plug and play with the fiber optic cable, then you will get a better litho angle with another laser.
So, well, feel free to contact me if anyone wants to be discussing with Murat. And also interesting for you and for Andreas next year, my colleague Jeremy is also planning in-person meetings about the AR/VR. So I'm sure you are already informed about this, but feel free also to check our website. We will post more information in the next weeks. And it's going to be in Finland, so it's a good environment for discussing about these topics. And thank you very much, Murat, for the presentation again. And we can go with thank you. We can go to our next last speaker today. We have Jens Krause, he's application engineer at Excelitas. He's going to talk about the high reliability 905 nanometers pulse laser diode in SMD package. So Jens, the floor is yours. You can share your screen when you're ready.
Yes, give me a second. So I hope everybody can see my screen now.
Yes, we can.
Perfect. So
thank you.
Thank you, Antonio and the EPIC team for having me today. My name is Jens, and I'd like to present you our brand new edge-emitting laser diode of the 3rd generation, featuring high reliability for the most demanding applications. Second here. So, okay, let me start with an overview of Excelitas, followed by a brief motivation of today's topic, which is obviously LiDAR, before jumping on the key details of our new laser diode. Excelitas is your single source for photonic solutions, covering many illumination devices such as lasers, also the transmission of light through optics and optomechanics, as well as the detection of light through several sensors from the UV to the far infrared are key competencies. This enables you to work with an easy supply chain, as Excelitas offers world's best components at various customization levels. Nowadays, everybody is looking for smarter devices. Machines need to be aware of their surrounding. While for pure measurement applications, no special precautions need to be considered. Things are changing once human lives got involved, as in AGV, industrial safety, or automotive applications. Commonly used technologies as cameras, radar, and ultrasonic are well established, but more and more 3D sensing applications are calling for LiDAR to increase the range, the robustness, and the resolution of distance measurements. Within our business line, we are developing pulsed laser diodes, avalanche photodiodes, and pin photodiodes. With our decades of experience in this market, we offer a broad portfolio on various components, configurations, and modules. Our edge-emitting pulsed laser diodes are typically emitting light pulses in the near infrared at 905 nanometers. However, this wavelength can be customized and tailored to your needs if required. Various chip and package configurations enable us to offer lasers with a large bandwidth of emission sizes and output powers from 6 watts to 360 watts. Our PIN and APD photodiodes are made of silicon or InGaAs and covering the full wavelength range between 400 nanometers and 1700 nanometers. But let's put now the focus on our brand new laser diode, which I want to share with you today. The 3rd generation of our laser diode comes as a catalog part in an SMD package, which can be mounted horizontally or vertically to the PCB surface and delivers constantly high output power for reliability demanding applications, such as in industrial safety. It was possible to increase the optical output power by more than 25% so that 120 watts at 40 amperes can be achieved. The laser diode features also a stable linear current to power slope of 3 watts per ampere without any rollover in output power at high currents. This chip generation will also act as a baseline for future developments, such as wavelength stabilizations and others. But I was talking about reliability. So why is this so important? When choosing the best suited laser diode, your system usually has certain requirements, such as the assembly technology, the wavelength, and the size of the laser diode to fit with the optics in the housing dimensions. The required power output needs to be considered, together with the repetition rate, the pulse width, and the package, to define proper operating conditions, which will influence the reliability, and with that, the mean time to failure of a laser diode. In cutting-edge LiDAR systems, especially high repetition rates at elevated temperatures and maximum current ratings are pushing semiconductor lasers to their limits. Excelitas has successfully demonstrated that its new semiconductor shows pristine and defect-free facet appearance, leading to higher damage thresholds of typical laser diode defects that impact reliability negatively. The new laser diode show very stable performance at high temperature operating lifetime tests, even after 3,000 hours of operations. These results are yielding a mean time to failure of roughly 41 years, which is significantly surpassing the most stringent requirements for, as an example, automotive qualification. However, as there is also an impact of the laser diode packaging on reliability at certain operating conditions, please do not hesitate to contact us through our webpage, channel partners, or EPIC to discuss your specific needs. Excelitas is offering customized products from chip to certain package assemblies. Today, you have learned about new high reliability laser diodes from Excelitas. Our Generation 3 laser diodes are available as catalog parts within SMD packages and feature 120 watts of output power. For specific applications, customizable offerings are our key competence, and Excelitas is committed to a resilient roadmap for future market requirements. With that, I would like to close this talk for today, and thank you very much. And for any questions, then please do not hesitate.
Thank you, Jens. Any question regarding the Excelitas solution? Which yeah, sorry.
Can I? Yeah. Hi, Jen. So I have a question regarding the structure of the PLD. Is it you showed the near field diagram with 3 stacks? So is that the case with third gen PLD? It's 3 stack.
Yeah, it's a micro stack. Yeah, three emitting areas within one chip. Yeah, exactly.
Okay, thank you.
I was curious about the kind of customers you are looking for, Jens, for this kind of product. Are they integrators of
yes,
laser manufacturers, integrators of other solutions?
Typical customers, we are addressing our OEM customers that are building up LiDAR systems. This particular laser diode features a high output power, so typically we would seek LiDAR manufacturers that needs either high range, but also in parallel to the increased efficiency, we have a very low bias voltage, so you can decide whether you have a high range, or maybe you are staying at the range you have with legacy laser diodes, but need less power consumption, which may be interested for especially these big warehouses, companies, or LiDAR developers that do systems for AGVs, for instance, because then in the end you have a longer battery service life and you need to recharge less your device.
And are you planning to extend the wavelengths for this kind of solutions, or do you think 905 is the main wavelength for this application?
905 is the main and will remain the main wavelength. However, we have our own wafer fab. We can process the wafer on our own. So if there is a customer requesting, let's say, something between 840 to 950 nanometers, that would be the range. We can do custom chip designs. And one thing I don't recall now if I mentioned this, but we are also looking into and working already on wavelength stabilization. This is always, let's say, something on the disadvantage of edge-emitting laser diodes, that you have a relatively large wavelength drift with temperature. But here we already have something enhanced to narrow this down and to be competitive here. Also, two different technologies that are on the side.
Very good. I don't know if there is any final question for Jens.
I have one more. So is it resin embedded, the packaging?
Sorry?
The packaging, is it resin embedded, the SMD package which you presented?
I'm sorry, I didn't understand the verb that you're using.
So the packaging, the SMD packaging, is it resin embedded?
Yes. It is, let's say, a common use substrate within resin on top. Yeah, it's encapsulated.
Okay. Yeah. Okay. That was my question. Thank you.
Thank you, Naveen, and thank you, Jens, for a nice presentation. Anybody in the audience that would like to understand more or discuss more in detail, feel free to contact directly any of the speakers and also myself. With this, I think we can close the session today. Thank you again to all the speakers. I can share again the agenda with you. So thank you, Naveen from Hamamatsu, Andreas from TOPPAN, Thomas and Kit from Arden Photonics, Murat from Optofidelity, and James from Excelitas. As I mentioned, feel free to contact us on Epic if you want to discuss more in detail with any of them. Most of them show their email addresses, so also feel free to contact them. And I hope to see you again in future events. I mentioned at the beginning some of the next meetings we will have, both in person and online. I encourage you to go to the Epic website to get more information about all of them, also the agendas, sessions, topics we will discuss. As I mentioned, it will be great to see you again in the next meeting. And I hope you will have a good month of September. I guess some of you are back from holidays. Others probably are working since August already. So in any case, good month of September for everybody, and see you next time. Thank you.
Thank you.
Thank you.
Bye-bye.
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 Bye.
Thank you.
Thank you.
I think almost everyone is gone.
Yeah, good.
Okay, then.
It's
have a
done.
good
Perfect.
afternoon.
I don't know if you asked this guy that put the question about the slides, if you answer him.
Yeah, I did, but it was already too late. He already
Okay,
left. But
I'm going to send him an email because I'm also interested in knowing more about his company, so I'm going to contact him.
okay, great. Yeah.
Perfect. Thank you,
All right.
Natasha.
Yeah, thank you.
See you.
Bye.
Bye-bye.